Let me introduce next speaker, Victor Vedmich from Amazon Web Service. His topic is chaos engineering.
Yeah, hello everyone. My name is Victor. I'm developer advocate. A little bit strange of naming of my, like what I'm doing. In general, couple words, what exactly I'm doing. I'm working with you guys, with builders who do some stuff inside in AWS. I create a lot of different content, most of them English or Russian because originally I'm from Belarus. And honestly, I'm very, very happy that we are, all of us today here in Mongolia. Super warm. I know during the winter you have a little bit colder than just like in the June. And yeah, so exactly today I'm going to speak with you about house engineering. What is it? When you need to apply? When you need to implement inside in your organization, in your project? And before I joined to AWS, I work as a system engineer or someone calls like DevOps engineer. And I remember the situation that one of the developer came to me and say, "Hey Victor, I have tiny changes. So I change only one line of the code. Let's deploy it to production. I'm guarantee it will work everything good." And as you can see on this funny GIF, what's really happened with my production? Everything was broken, and nobody didn't understand what's exactly happened. Why is this line of code just like to bring to us to the situation that everything was broken? Yeah, so and it's house engineering exactly help us to prepare for such kind of situation and don't be in this situation that when you do some small stuff, your like production is going down totally. And we have to be prepared for downtimes because downtimes it's affected our business. And based on the researches, for example, from Gartner, 1 minute of downtime costs around $5,000. Yes, from Gartner. For startups, for example, again, it's like it depends, of course, of your size. Like organization, how many users do you have? Maybe if you have only 2 users, of course, it will not cost like $5,000. But if you're a big company, and for example, if you're part of 100, yeah, if you're part of, sorry, it's a little bit slower than I see on the screen. Yeah, so if you're included in this Fortune 1000 company, your downtime will be cost $1 million. But what's exactly downtime? What kind of phases happened if something happened in your production? And I want to go with you through this journey from one step to another step to show what's exactly happened and how you can react in every stage. Of course, everything started from disasters, like something happened, yes, so we have a problem, I don't know, for example, our customer cannot connect to our application and got some errors, like for example, 500 errors or something like that. And we start to investigate because we need to understand what's really happened with my application, and it's a phase of evaluation. So in evaluation phase, we are reading our logs, we look at the monitoring system if we have, of course. And like during my presentation, you will hear about monitoring a lot of time, because in my personal opinion, monitoring is the heart of house engineering. First of all, you should install and configure your monitoring system. So the first phase is evaluation. You try to understand what's really happened and why, what's the root cause. The next phase is response. Response, it means like you prepare something to fix this problem. For example, if it's a problem from the code perspective, you prepare to fix bugs. If it's from an infrastructure perspective, you replace some, for example, virtual machines or some services or endpoints or something like that. So you doing some stuff. So you're prepared to deploy it, to update your infrastructure or code or something like that. And also you don't want to be in situations that new changes, this new fix will bring more problem. So you try to be careful because it's very critical, it's very, emotion. I mean, like you understand, like everyone currently cannot use your application, high pressure from your boss, from your CTO, for example, or CEO, say, "Hey, Victor, let's do it, let's deploy something." So we deploy, and the next phase, it's not the finish of downtime. Yes, we deploy something, we see that our application works fine. It's from our perspective, we think that everything is fine. We on the phase of the recovery. But on reality, downtime finish when we got the confirmation from our customers. When I say it, confirmation, I mean, for example, we see the same amount of requests. Like, for example, before the downtime, I have 5,000 requests per minute, and currently I see almost the same amount. So it's how it looks like downtime. But you would say, like, I understand, it's downtime, and most probably this will happen when we are working with distributed system. And you're absolutely right that when we create any system, most probably it will be distributed system. And distributed system is very hard. And if you look at that, for example, from big company like Amazon, Twitter, Netflix, it's after discovered microservice configuration. See here is switching, but not, you don't see it. Okay. See, yeah. So it's how it looks like, for example, in Amazon or Netflix, and you would say, I am not Amazon. I am like small business in Mongolia, and I do some very simple stuff, yeah. But at the same time, I'm 99% guaranteed that you're doing distributed system. Because anyway, you will do client-server communication. And just like, let's look at the example how we communicate with the client and server. I don't want to push button again because I see it here, it's like switching to the next slide, but yeah, finally. So let's see, it should be some animation, and I hope, yeah. So what we can see on this pretty simple slide. We started to communicate with our client, and from the client, no, not work. Switching, okay. So I see here's something else than I see on the screen. So our client sends a message, and the message sends through the network. We communicate through the network with our server responds that I got the message, send it through the network again to the client said, hey, I got your message, and so on. So if I go through all the steps, it's this super simple example to communication between client and server. We will see 6 steps. And in every step, something can happen. And it's really difficult to predict and say we will have some problem during the network communication between server, for example, and my client. So we have to be prepared for that. I don't want to say that we don't need to write any, so like everything just like go down. So I don't want to say that we don't need to write any unit tests. Unit tests or some another tests, it's what we know about our system. It's our scenarios, how our system works. And of course, you should to write unit tests to be prepared for that your known situations, that your known functionality works correctly. And but anyway, we have to be prepared that something can be broken. And as our CTO said, Werner Vogel, at any time, everything can be broken. So we also have this situation that sometimes our data center is going down. We try to learn from our mistakes, from our, like what we did wrong, and do it in the next time better. So house engineering exactly try to help you to figure out what kind of unknown situation can happen in your cluster. But let's see super simple another example. Just like, for example, you have a server, like virtual machine, yeah? And you got some error from your system, and you don't understand what's really happened. It's super simple. Why? Because you have some storage, like for example, 10 gigabytes of memory or 100 gigabytes of memory, and you set up a lot of logs in your system. And the space of this storage is finished. We don't have any more. And for example, for load balancer, and if you use super simple distribution like round robin, for load balancer, this serial looks like fine. I can send additional message to this server. But at the same time, I will get some error. And we can fix it and figure out very quickly if we have a monitoring. Again, monitoring for house engineering is super important. We can set up, for example, some life cycle of our logging and delete these logs. That's how, like one of the example, what can happen with your situation. You cannot predict that, for example, free spaces on this virtual machine will finish like in 1 minute or in 1 hour, if you don't have a monitoring, of course. So how house engineering can help us in this situation? So first of all, house engineering can help us to see your system, how it looks like in turbulence. Like for example, if I have some issue which you don't know, it's unknown situation. And if you look at the definition, exactly definitions of what is house engineering, we will see that it's, you see it, like next slide is coming, it's coming, it's coming. Yeah, finally. So house engineering is a discipline of experimenting on system to order, build confidence in systems capability to wisdom, turbulence, condition in production. It's very important to understand that house engineering is first of all engineering practice. It's not doing some random stuff. For example, when I spoke with many clients and spoke about house engineering, they thought like, okay, let's do house engineering. I'm going to do like on my production. And the same situation on, I hope we will see this funny GIF. Please. It's playing here, it's here, yeah. So let's do some stuff on our production and break, for example, let's turn on this couple of servers and try to fix on the production. It's not about house engineering. It's not like on this funny car and try to fix with a wheel and replace it between we are just like, we are driving on the road. It's not about house engineering. If you think in this way, you're absolutely wrong. House engineering, it's a practice engineering. And I want to share with you or some steps which is included in house engineering. And the first one is steady state. What exactly it means? Like you should to understand what your system state currently is a health state. It includes your monitoring system. You understand how your system works. You have your unit tests, for example, function tests, and so on. You understand how your system works, and the next phase, you can set up some, like, for example, hypothesis. Hypothesis means like, what happens if I, for example, turn on some virtual machine, if I delete some files, for example, and so on. You prepare the experiment, so you create this hypothesis, run experiment, got the feedback, understand like, okay, verify my experiment, it's my hypothesis, is the same as I expected or not. Maybe I was wrong, maybe I need to do something else. We got the verify, and as usual in continuous improvement, continuous integration, in general in development process, we improve our system. But if you look at the, for example, in our local data center, how to do house engineering, sometimes it can be very difficult. Why? Because we need to set up a lot of systems, like maybe homemade scripts, maybe we need to set up some additional agents, to control our environment, for example, to turn on something, to turn off, delete some files, kill process, and so on. And as usual, just like in Amazon, we create a lot of services. Most of these services we create based on your feedback. We try to listen to you. At the end of my presentation, for example, I also is going to ask you feedback, what you think about my presentation. And in Amazon, you can try house engineering practice on your system. My recommendation not to start from, from production, try to do it on your test environment or staging. Fault injector simulator. It's very great tool which can help you to do different stuff from house engineering. So it's easy to start. Again, I see slides here, it's already another, but not here. Yeah, so easy to start. I will show what this means like. Related to real-world condition, because we will try to simulate what exactly happened on my production, and it's safeguard. Again, everything I'm going to explain. Easy to start, what this means. When you think about house engineering, most probably from you had some story from Netflix, House Monkey. Anyway, you need to set up something, you need to write your own script. In fault injector simulator, you don't need to do anything. Just like you create your own experiment and start to experiment with your hypothesis, verify, and improve your system. Easy to start. Okay, next slide. Yeah, okay. Real world scenario. When I said real world, I mean, for example, in my situation, when I describe tiny changes of one line of code, in reality, in this situation, what really happened was not related to this line of code. We got some external error from a third-party solution, and it's bring to us this situation. So when I speak about real-world situation, it means like something happened, but maybe it's bring a lot of type of activities and bring to this situation. I mean, like for example, I made the changes. Also networking, for example, throughput is going down or something broken during the network communication and something else. In the fault injector simulator, you can create the real world, like for example, simultaneous actions or parallel actions happen at the same time. And safeguard. Safeguard, it means like you have a safe place. You don't play with production database. You control what kind of resources you are going to affect, what kind of resources you want to, to make some changes. Because, for example, to implement house engineering for stateful applications like databases, it's really risky because you can lose your data. Be very, very careful. So let's go to review just like in components, what's included in fault injector simulator. The first one is action, what we are going to do, our target, exactly on which system or some components we are going to apply our experiments, templates. This templates is stored as JSON, so it means that you can create your experiments and run in your continuous integration pipeline. So let's look at the simple diagram, how it looks like. Yeah, here we go. So from left side, in your situation, from left side, we have the fault injector simulator, which integrated with access, with AMI, access management identification, and you can control what kind of resources can be affected by fault injector simulator. We have your own system. You also have experiment and monitoring. You can integrate with fault injector simulator external monitoring, for example, New Relic, or you're working with Zabbix, go ahead, it's up to you. But it's very important to have monitoring, because monitoring will help you to say, let's stop this template, let's stop this experiment, because we got some error in our experiment. So what exactly we can do with fault injector simulator? Currently it's available a couple of actions, but we are growing and add more and more and more, and more. Yeah, so we can start, for example, EC2 instances. We can kill, for example, some process inside a virtual machine. We can, for example, block DNS resolution. We can delete some files inside of my virtual machine, and so on. I don't know why, but it's not switching to the next slide. Let me try again. No. Okay, next slide. No. Let me just maybe do in this way. So look the magic. What kind of demo we are going to do? Before we jump into exactly to fault injector simulator, I want to describe you what our environment is. And I have some internal application. It's super simple. It's like, social platform where I can post some messages. It's currently available on multiple platforms, like on tablets, on web browser, and so on. And our CTO said we have to prepare to publish this application outside. To make this application publicly available for external customers. But we are not ready to do it. We have to do some stuff, and we want to run some house engineering practice. So it's how it works. I'm the user 1, 2, 3, and post some messages. It's like super simple application. Let's look at the diagram, what the components currently included in this application, how I deploy this application. So I have super simple two-tier application. On the top level, I have load balancer. I have autoscaling group with one instance. You ask me why I have autoscaling group only for one instance, and my answer will be, if you lost this instance, yeah, of course, if you lost this instance, maybe something happened. House engineering in practice. So the question here, why I need one autoscaling group only for one instance? If you lost this instance, nothing happened. Okay, if you lost this instance, autoscaling group will replace this instance. It's also a mechanism to be more reliable, to be more, if you make some mistake, autoscaling group can help you. Also, we have RDS as our database instance. And let's create our first experiment. We remember house engineering is engineering practice. So it means like we have to create our experiment. And when we create our experiment, we create hypothesis. And our hypothesis will be, what will happen if I turn off my EC2 instance? Of course, I should lose the whole access to my application. And if I turn back, like turn on this instance, I should get access back to my application. And so my experiment designer is going to stop and start instance. Also, the target, it will be my single instances. And here we go, let's do it. Let's do our first experiment. Let's create this one. So we currently based in AWS console, fault injector simulator, and is going to create our first experiment. I define the name of the experiment. It will be a stop start single instance. Also, I set up just like some attacks to find as a future this experiment. Also, I selected the right EAM permissions. So in fault injector simulator, you have fully integrated to EAM permissions. It means like you can control what you can do, what kind of resources can be affected. For example, only staging environment or development environment. Also in action, I'm going to set up the name like stop start instance, description the same, just like and select the action. So the action is what currently is available, what you can do with fault injector simulator. At the end, I also describe what kind of actions is available. So in 2 minutes, I'm going to turn on back my EC2 instance to make sure we remember, yeah? My hypothesis currently turn off, application doesn't work. Turn back, like turn on, application is available. And in target, I select, currently I have only one instance, and I want to demonstrate for you that I have only one instance, and select a resource ID of this EC2 instance. So currently, as you can see, only one instance is available. I select it, and also switching to EC2 instances, yeah, you can see one instance currently is running, so we select this instance. Let's save it. And also we have stop condition, but currently we didn't set up any monitoring system. For that reason, I cannot set up stop condition. I don't have any alarms, alerts, and so on. So let's create this experiment and run this experiment. In action, I'm going to select and say, let's start this experiment. I want to highlight it again. This experiment can be exported as JSON, and you can run this experiment in your CI/CD pipeline if you want to run as continuously, I mean like in continuous integration process. So we run our experiment, and I'm going to check what's currently is going to really happen with my system. Currently is running. Let's refresh the page of my application, and let's check that, yeah, my currently EC2 instance is stopping. It means like it's like currently stopped already. Let's refresh the page. Of course, 500 bad gateway, of course, because I lost access to my EC2 instance. And just like in 2 minutes, fault injector simulator also turn on and back to my EC2 instance. And if we back to my application, first of all, let's check the state of EC2 instance running. And back to my application, if you refresh it, we will see that my application works fine. So it was our first experiment. What else we can do? So how we can improve our application? What we can do with this diagram? And as I mentioned, the main and core system of house engineering is monitoring. And if you have only this, like this architecture and don't have any monitoring system, you have to do monitoring system. And our next step, of course, implement monitoring. Understands what's really happened with our application, is available, not available, and set up stop condition. So let's create another experiment. In this experiment, I already prepared, like some alarm in CloudWatch, but I want to highlight it that fault injector simulator can be integrated with your external monitoring system, like New Relic or something else. So again, I'm going to update my my experiment, and in this time again the same target, the same one EC2 instance, and in stop condition I'm going to select the alarm. Alarm currently is what exactly this alarm is doing. It's checking that my application is available. I mean, send the HTTP request and get this request. We got some content on this page or not. If yes, and we got the right content on this page, alarm is green. If not, it's red. So let's run our experiment. It's currently is running, and if we look at my alarm is red, it means like we got event. It's like something happened. And if we switch to experiment, we see stopped. So it means like I got alarm, I got some problem, and I stopped this experiment. It's how it looks like. I mean, like what you should do with house engineering. You should not turn off the whole of your production. You should be controlled when you have to stop your experiment. Okay, what we can do the next one? Of course, all of you will say like, we have only one instance. We need to scale these instances and add more. And let's do it like we can add more instances because we have after scaling group. It's super easy. In after scaling group, you can control minimum desired and maximum capacity. And let's say for me, currently desired will be 3 instances. So, and let's do another experiment. And at this time, I'm going to stop instance again. And my hypothesis will be, if I stop only one instance, my application should be available. If I turn back again this instance, nothing will happen. My alarm will not be, in red state. It means like if I lost one instance of the group, nothing will be affected. This will not affect my, in general, my system. So what exactly will be included in my experiment? I'm going to stop and start instances, and I'm going to select only one instance from after scaling group. We will see how we can do it. And currently, as you can see already, I scale and we have 3 instances is running. So I'm going to create new experiment in fault injector simulator. Again, almost the same stuff will be on the first part. I mean, like, again, we are going to stop start instances. EAM role will be absolutely the same because I'm going to affect only EC2 instance, and through the EAM I can control that, yes, I work only with EC2 instances. In target, in action again the same stop start, but in target it will be a little bit more interesting. So in the first experiment, like what I showed previously, we selected one resource ID, but currently fault injector simulator can randomly select one of the instances. And for example, in your situation, you can have, I don't know, multiple resources, many resources, and fault injector simulator can select randomly some of them and affect them. And for example, in my case, I'm going to say I want to have some filters based on the parameter text and say resource text should have key and value. In my case, it will be FIS fault injector simulator target. It's true. Also, I want to affect only instances which is currently running. So I want to stop instance which is running, not stop instance which already stopped. So I define it as state name is running, and number of resources, like I can select in selection modes how many resources I want to affect it. And as said, only one. Stop condition, again, it's my monitoring. I select the same alarm and create the experiment. Let's try to run this experiment, and what we will see in this situation. Start, confirm start, as we understand what we are doing. And currently it's pending. It means like we are starting this application. Under the hood, it's run Lambda functions for you. I mean, like it's created based on Lambda functions and control all of the resources through the Lambda. So we see that my alarm is currently green, so I didn't lost my application. It works fine. Let's double check. Let's post some messages. Yes, like user again 1, 2, 3, or something like that, and hello. Oh, something like that. It works, yeah. So let's post it. It works. So and currently, if you look at the EC2 instances, one of them was stopped in a stop state, and just like in a few seconds, we will see that my experiment will finished or not. Yeah. So I understand that it's only start what you can do with fault injector simulator. And my personal opinion, it's very great to hear me here. It's like it's very great that you come to community day group. Thank you very much. But I believe you have to do by yourself. And workshop, it's the best way. So what I show you during this demo, it's honestly it's a part of this workshop. And if you prefer to play by yourself, I mean like to understand what is fault injector simulator, what is house engineering practice is, you can try to use this workshop. So let's a little bit to summarize. What kind of another activities you can do with fault injector simulator? So you can detach, for example, UBS volumes. You can delete some record in your host file. You can kill some process or block DNS resolution. You can do multiple different stuff with fault injector simulator. And also, for example, to simulate spot instances, termination, and so on. To summarize, again, guys, it's very, very important to have a stop condition. Your monitoring system should be a main central part of house engineering. If you don't understand your current state of system, you should not start house engineering. First of all, monitoring. You should understand what exactly you are doing and start with the small things. I mean, like, not need to turn off the whole data center or kill the whole production. Start with the small things, like what I did, like turn off one virtual machine and look at the what's really happened. Minimize the blast radius. Blast radius, it means like how many resources you affected. For example, we currently working on the EC2 instances. Continue in the workshop, you also will affect RDS. So you try to control the blast radius. What exactly you are going to affect? Safeguard, carefully doing like what exactly you're doing, and be very, very careful with stateful applications with RDS or in other databases. And I want to finish my presentation with another definition of house engineering, and I believe it's, for me, it's a little bit better than the official. And house engineering is not about breaking things randomly and do some, like some fun stuff, because when I spoke with the people, they thinking, house engineering, it's turn off the whole data center or kill multiple virtual machines or do some like random stuff. No, house engineering, it's engineering practice, and you should implement as any engineering practice, step by step and continuously to see what you did and prove in continuous improvement system. And as already mentioned, Amazon is really like hear your feedback. And I would very happy if you leave your feedback about my deck, about my speech. Maybe you prefer to hear more about, to have more demo, or you want to hear some another topic, you can type in text field. So just like go ahead and leave your feedback. 3 questions, yeah?
За асуулт байвал 3 асуулт авъя.
1, 2, 3. 1, 2, yeah.
Hi, Igor. Thank you for the great presentation. So my question is, for the startups, like it's a small number of developers, so they don't have resources to like apply like this kind of chaos engineering practices. So what is the what do you think about the minimum number of the resources or the customers they have when the startups should implement the chaos engineering in their continuous integration practices, something like that?
Honestly, I believe that you should start on not like on the first stage of your development. Maybe you need to have your MVP, like minimum viable product, to show and get some investment and get some money. But the next phase is, it's usual, like as soon as you implement the best practice, like continuous integration, if you're doing like in your local machine, deploy from your local machine to the production, it's not best practice. Many people would say for you, continuous integration is very important. The same stuff I would say with house engineering. You can do some small part of, like small experiments, not to try to do some complex and fancy parallel experiments, but try to implement it and use in continuous integration pipelines. Because the main idea of house engineering to understand what will happen in unknown situation. Function tests, unit tests, it's known situation. You know your business logic. You just like, for example, writing a function which calculate 2 numbers like plus A plus B and got the result. It's your known situation, like your success path. But with house engineering, it's provide for you understanding of reliability of your system. And the same, like I understand that sometimes people thinking I'm the startup and I have to do new features because it's more important. But as usual, it's like trade-off when you have to stop and make some improvements, refactoring of your application, implement the best practices like continuous integration, infrastructure as code. Because I know a lot of startups starting to work with AWS and create all of their resources in console, just like clicking, 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 clicking. It's not best practice because it will not be scalable in the future. So the same stuff with house engineering. As soon as you are ready. So my answer, it's not at the first stage. As soon as you got some MVP and your application is ready to implement some best practices like continuous integration, infrastructure as code, monitoring, you finish with that. As soon as you got monitoring, understand your system, like how it works, implement house engineering. Very, very small, like control blast radius, do some small stuff, but at least start to do it.
Okay. Thank you very much.
Okay, thank you for your presentation, and I would like to ask one question, just one. So, for example, in your presentation, I understood that we have to create a scenario where the system is going to, fall or fail or going to happen, right? So we have to create a scenario by ourselves based on our intuition or our feelings, right? So let's imagine I have did the chaos engineering or fault injection simulator and then 5 or maybe 10 times, and then after proceeding those 10 steps, I have no idea what should I do to test out my system again. So in that case, the fault injection simulator is going to offer something, or what should we do in that step?
It's common situation. Many people ask me, do you have some template which I have to implement inside in my application? No. In fault injection simulator, you have some actions. You can look at these actions and try to, generate some idea what you can do. For example, you have Kubernetes cluster. What will happen if I kill kubelet inside and working nodes? Let's do it. Or you have some web application. What will happen if I block the NAS resolution? Let's do it. So in general, so it's not provided for you some ready templates. You can find something in AWS samples GitHub, but it's not what you have to implement in your own system, because every system is super unique. In my situation, I had only load balancer, EC2 instance, and databases. Maybe in your situation, you have Kubernetes, Lambda functions, DynamoDB, I don't know, SQS, maybe something else, different services. And look at the whole of your architecture and try to understand, okay, what will happen if, try to create your hypothesis. It's the main idea of house engineering. And also another part is when you create your scenario, run the scenario continuously. Because as I mentioned already, it's JSON. You can run as a part of continuous integration. Maybe you did something, new feature, you split maybe some of the microservices, and currently if you lost something, you lost the whole application. Because when we look at the distributed system, and if I lost one microservices, you never would say like, if I lost this microservice, how it affects the whole system. So run constantly these experiments and see how it affects your system. Because you're developing, you're creating something new, a new feature, splitting maybe logic of functionality of microservices, migrate some functionality from microservice A to microservice B, and if you create on the start some templates step by step, just like it's part of continuous integration best practices. But again, long story short, no, but we provide some actions which you can just generate idea what you can do.
Okay, thank you very much. If you offered that, then it would be awesome in the future, right?
It's very difficult, as I said, because every system is super unique. It's very difficult to create some silver bullet for everyone.
За, дахиад асуулт асуухгүй бол.
Last question, and we have to move because I see I spent almost 40 minutes. Yeah.
Сая нэлээд monitoring tools suggesting that we should have to have monitoring tools, right? In my case, I use Zabbix.
Okay.
What any other better tools, something like Zabbix, you can suggest us? Monitor.
New Relic. No, but New Relic, it's not so cheap, honestly. Yeah, so Prometheus, Grafana, it's the best tool, open source. What you can do and how you can set up. In Amazon, Prometheus and Grafana is available as managed service. And in Prometheus, you can set up collect all of your metrics and set up your own alerts. Integration with fault injector simulator, it's going through the SQS. It means like you create some event and send it to queues, and fault injector simulator look at these queues and see, hey, I have something in the queue, let's stop my experiment. So you can do it through Zabbix. Zabbix, I would say Zabbix is not the best solution. I worked with Zabbix. It's good if you have only EC2 instances. They try to to develop new, but the best one currently is if you look at from open source Prometheus 100%. If you have money, New Relic will be the best choice. I think that's it, yeah, because I know we have very time strict, so I finished. Thank you, guys. Thank you very much.
Yeah, thank you, Victor. Such a great presentation.